Oh, wow. So this is interesting. Do I hold the mic in the clicker? Do I hold it in my right hand? Do I hold it in my left hand? Do I just leave the mic here and then stand close to the podium? I don't know. So you might see it swap up a little bit during this talk. But today I'm going to talk about logs, metrics, endpoints, and traces. And some of you who've been doing this stuff for years, I have been in the monitoring world for literally decades. And you're like, why would we talk about something so basic? And what it comes down to is this. I've been literally in the monitoring world for 20 years, and I mention these topics to people, and we still get it wrong. So guess what? This is Logs, Metrics, Endpoints, and Traces, 104, the remedial course. Let's bring it back to the basics. All right. So who am I? Oh, that's really neat on this green stage. I actually, hold on here. That's pretty dope, actually. I look really good on green. But I'm Bryan Liles. I am a senior staff engineer of the Tanzu Build project at VMware. That's a lot to say. The reason I say my title is because two things. It's a pretty dope title. And two, I am literally the highest ranked black engineer at VMware. That's crazy. And it's so crazy for two reasons. One, yay me, but two, we can do better in the industry. So I say it all the time so people can see someone who looks like me does these types of things. The other piece is Tanzu. That is not Tanzu, it's Tanzu. It's a new brand from VMware where we are actually doing some pretty crazy cloud native stuff, and I'm actually the tech lead for this part of the project. I also run a little conference called KubeCon. Anyone ever heard of KubeCon? I think we might have 10,000 people getting together in San Diego next month. And I'm a co-char. Wow, that's the only typo you'll see on my slides of the CNCF SIGApp delivery, which means that I am super interested in how people are delivering apps from whatever they call development to whatever they call production. And so I give myself another title. I'm a developer's developer. I develop tools for developers. So I broke this talk up into chapters. It's kind of like a story. And I really wanted to tell a story. Originally, I wanted to just live code the whole entire thing, but I'm actually not from Baltimore anymore. I just moved closer to DC a few months ago, and I've spent all of 4 days in Maryland, so the whole live coding thing was like not gonna happen, so we're gonna get slides and chapters. So let's talk about logs. Actually, what is a log? And the reason I bring this up is because if I ask 10 different people, I'm gonna get 14 different replies. What is a log? Well, what kind of log is this? Let's just shout it out. We're friends. It's an Apache access log. Pretty cool, you know, it has some IPs, date, some timestamps, the verb, and the path, or actually the URI you're trying to request, the HTTP version that you're using, and the status of that, and the size of the response. Kind of neat. This is a log, and Apache thought it was so good, they created what? The Apache extended log format. What is this thing? Actually, I just took this from the internet. What is this thing? It's just a log. Well, really what it's trying to show you is that your log tool actually might really influence the kind of logs you create. So in this case, what we have is a log for some kind of application. It looks like some kind of visual application because there is a create layout on here. Actually, no, I'm lying. I don't know what kind of log this is. And this is the point that I was trying to make, is this is where we get. We create logs and we don't understand really what should be in a log. And here's another log. I do a lot of Go, so I had to add a Go example here. And now here is a Go log, and it uses colors to show what the log levels are. And there's a date and time stamp. And ooh, there's a file line in there too. That's helpful. And what else do we see in here? We see a message, and then we also see some colog equals yes on the end. So they added a little bit of extended metadata on there. So taking these three types of logs and combining them together, I think we can find some good things in logs. So what I found, and I did a little research, log levels. So we have debug, put debug data in there. We have tracing, we put tracing data in there. What's the difference between debug and tracing data? Actually, I don't know, but people are using it. And then we have info. Info is, you're reading this, and you're reading our logs, and you want to have some info, so we'll put it here. And then there's notice. Notice is different than info because we want to make it formally that we are informing you of something in your log. Then there's warning. Warning is, well, not quite bad enough to be red, but definitely not good enough to be green. So we're going to make it a warning, like maybe you should not do this. And then we actually have error. Error is a good one. Error means something went wrong, of course. But then we have critical. What's the difference between critical and error? Well, you can have a critical error. What is critical? I don't know. Then you have alert. And alert means that we're creating this and we should alert you, maybe the operator or the owner of this application, that something is happening. And then we have emergency. Wow. Logs have levels. So I'm here today to say that if you're doing this, stop doing this. Let's just go down to the 4 log levels. Debug, info, warning, and error. And the reason is because if we have too many log levels, people get confused. Like I was saying before, info and notice, or info and notice, or trace and error, they're pretty difficult to determine. And if you tell somebody, they might not understand. So debug logs. This is logs that you use that will help you debug your application. Pretty simple. Info logs. Info logs are the normal log messages that you will have, like something happened, this happened, I created this. Warning. Warning, I don't ever really use warnings in my code, but warnings are for whenever you have something that is not a problem, but something that may be out of bounds. And then error is, hey, there's an issue here that might need to be fixed, or I can't recover. So logs are for humans. Logs are for computers. Which one are logs for? You can just shout it out. It's cool. Right. So we created this one term called logs, and we basically gave people shovels to put in our wheelbarrow of whatever's collecting our logs. And we are using logs for computers and using logs for humans. So basically what it means is that we get something that's not readable, like I was showing you, that could be actually worse than that Java example that I was showing you. So what do I tell people to do? Well, log in JSON format, please. And I can debate you on how to say JSON, JSON, JSON. It's JSON. I'm on stage. I'm right now. For the next 20 minutes, I am perfectly right. It's JSON. And I will die on that hill too. But the thing that I was saying is that we should log in JSON format. Why? Well, because we can have log messages, and then we can have metadata attached. So from this other log image that I plucked off of Google, where we have an action, and we have a nick, and we have a pretty nick, and a server, and a text, humans can actually associate the key with the value. But computers can come through and automatically pull this data out. So next time you have a log message that says, I created a user, or I created an order, annotate that log message with the date and time, maybe what type of order it was, and now your computers and your users can get this information. And the cool thing about this is that you can also throw errors in here as well, and then we can actually use tools to pull out our errors. And like I said, I will die on this hill. Use JSON. So what should be logged? Well, 3 simple things. What would be useful for you in a debugging session? So if you have an application, and I actually do have a couple of open source projects, and one that I have for Kubernetes is we are doing communications with something called an informer. And an informer goes out and it collects data from an API periodically and then reconciles it in memory to have it available local so I can query the cache, the local cache, rather than the remote source. Saves on network traffic. Sometimes when we're getting data from the informers or we're not getting it fast enough, it fails. We log that we are using the informers. Could you use the log to rebuild a data stream? Well, this is interesting. I like it. I would like to be in the place where I could actually use my logs to figure out not just what happened at a point in time, but actually work backwards to figure out how I got there. So I'm not saying you should do this, but you should think if is it possible, and then can we get closer in this direction? And then also, when you're thinking about what should be logged, does the consumer have enough context? You can't just log, it broke. We all do this, especially whenever we're doing like tracer bullet development. We put it in there, got here, got here, got here. But before you commit that, please take it out and say, or leave in something where got to step 5 of this process so the user knows how to do it. So logs, we're all experts. Let's move on. So best practices. And this is not the controversial piece. We've spent a lot of effort figuring out how to do logs. I have a good friend who actually maintains the rsyslog project, and he can tell you about logs at scale, like crazy scale. For us normal developers, at least myself, we log a standard error, or standard out. That's it. You have a log message, put it as standard out, unless it's your CLI application, and maybe put it somewhere else. But if you're not, log a standard out. Make sure you're using JSON for your logs, add context to your logs, and highlight errors, and then take advantage of log levels. A log is not a log is not a log. So moving on, metrics. And I wanted to throw some controversy out there today. And actually I had a longer quote earlier, but I took it back because I thought it was mean. But I'll read it. Before we learned about metrics, there was Nagios, and it was not good. And a lot of you are laughing because you're probably saying that, hey, Bryan is saying Nagios was not good. Actually, Nagios was amazing. And before Nagios was amazing, NetSaint was amazing. And the reason why it was amazing is because it was the tastemaker. You don't know that you don't like squash until you put it in your mouth. And with Nagios, what we learned is that monitoring good, this, not so much. And I don't want to just throw that out there without an example. So with Nagios, you had plugins, and it was pretty cool. The whole premise was you can install Nagios, and then out of the box, you could monitor a whole bunch of things like disk space and things like that. But then you could write these plugins, and you could literally monitor anything. And better, you could throw out metadata for literally anything. And this is an example of this. So this is a disk-based check for a host. And it says disk OK. All right, well, I can agree with that. So we have free space, and root is basically about 3 gigabytes, which is 56%. But then we have this colon, and then we have slash equals 265, basically 2.6 gigabytes, and then we have a semicolon 5948, semicolon 5958, semicolon 0, semicolon 5968. Does anyone know what that means? I mean, I do know what it means, but could you hand this to your next person on call, and then could they read this without actually understanding? Well, maybe if they understood how Nagios plugins work, but I think we can do better with this. So Nagios, a la NetSaint, whatever you want to call it, showed us that there is value in being able to supply this data in a consumable format. They fell a little bit short with making it consumable for everyone. So what I wanted to do, actually, surprise, I actually wrote out what it did. So this is funny. I create these slides, and then I do a talk, and then I do another talk, and then I give the slides from this talk that I created 3 ago, and I just forget what was in there. So really what's going on here is that the red portion is showing us what's going to be in one macro, which is called the service output. The orange is going to be in another macro, or basically in another macro, and then the blue will be in another macro. Super confusing, but we can do better. But before I get into how it could be better, let's talk about push versus pull. And I know there's a lot of vendors here today. who will not agree that pull methods, a la what Prometheus does, is the right way to do it. And they're actually doing pushes. And that, I think, actually, I'm not here I won't die on that hill. I really don't care. Prometheus is just the right answer. But think about this. When you produce metrics from your application, are you pushing it out to something that can be aggregated to some central function later? Or are you basically just making it available and then whatever functions want to pull it out can get it? So if you think about this, I don't want to code all the logic of the world into my app. Pull is better. So what's a metric? Well, the problem is, in a lot of cases, and I think we're getting better about this, and shout out to Google for the SRE book, and shout out to others who have written and talked about this subject in the past, but this whole subject of SLOs, SLIs is actually a good one. You cannot, or you should not define metrics until you understand what these metrics are actually defining, because just having metrics is not a great idea. But if you have an SLO, I need to serve requests from this service at this capacity with this amount of errors at this speed is great. So let's go through ways of doing this. So we have the use method, we have the red method, and because Google is Google, we have the 4 golden signals. They're all good, and they're all useful for different things. So let me break this down real quick. So we have use, and this is utilization, saturation. I'm from Baltimore, I can't say certain words. Saturation, and errors. So basically what this is saying is that I understand how this application works, and I should be able to publish metrics that say how this application is being utilized. You know, are we at 50% or 20%? Then I can say how much is being saturated, given I have this much capacity, what is my saturation? Or how many errors? Pretty interesting. And then you have another method called RED, rate, errors, and duration. This is probably more uncommon now because we have tools that are inspecting the outside. And let's say that we know that we're talking HTTP traffic. We can definitely determine the rate of how many messages are going across. We can definitely tell the errors because we can inspect the return code of the HTTP status, and we can look at the duration. Something went in, something came out. What's the difference in time? So, like I said, useful for black box metrics. And then there's the 4 golden signals, which actually I think is a good pair for RED, the RED method, where we're looking at latency, traffic, errors, and saturation. And I sat and thought about why this is and why Google would have created this. If you're operating at Google scale, where sometimes you're not thinking about individual services, you're probably thinking about pods and clusters, and I'm not using their terms, big services. Sometimes you don't really care about the small granular things. If that rack is broken, we just throw it away. So this is another way of specifying what's in red. So, my gosh, still talking, what's a metric? Let's rethink this. So I broke this down, and this is kind of like my Prometheus primer. So a metric is this. You have something and you have a value. So we give it a label, HTTP requests total, there's 5. But what we should also think about with the metric is the context that which is working in. So now with Prometheus, we can do HTTP requests total, and we can say only for method post. So we have 5 post methods in total. But we can do better than this because we can actually have multiple labels where now we can say, show me a counter of all the HTTP requests that are posts that are a bad request, and we have 5. And even better yet, because we don't know when we're getting pulled, we can actually set a timestamp to say when this message happened. Because now we're saying that HTTP requests total method post code 5 at some timestamp. I'll let y'all figure out what that timestamp is later. So that is I said counter before, but this is actually a gauge. It can actually move up and down to say how many is happening. So we can basically say that it's 5 now, and it can go down to 4. We can also use counters, which are basically just count up. So we have a flux, and we're counting flux failures, and now we have 5. And later on, we can have 7 or 8 or 9. It'll never go back down. So here's another interesting thing, and this is probably what I just wanted to put on slide. This is what the whole talk is about. What a histogram is. I've been using Prometheus for a long time, and I read the docs, but it took a while for it to click what a histogram was. And what this is showing you, and this is a set of metrics, is saying that we have a request time in seconds. And what we're doing is we summarize all the, we can basically have a sum of the time of all the request time seconds, but then we can break it down into buckets. So we can say that items that took place in less than 5/1000ths of a second is this number, all the way down to 15 seconds. So now we can actually categorize our metric over many different buckets. And if you think about this, if you're counting nines, so if you're going from like 90 to 99, 99.5 to 99.9, and out to how many ever nines you need to go, you can actually determine what your requests look like, so you can determine if you're actually hitting your SLO. And then down at the bottom, there's a count. And you can put this all together to make some pretty interesting graphs. And then there's another one in Prometheus called Summary. And what it does is, instead of just having buckets, it uses quantiles. So now we can actually, in the first speaker's talk, there was an error bar, and we can actually break that down, and we can actually see exactly where our connections are. So why metrics? Why should we create metrics? Really, it breaks down to this. We want to create metrics for things that can be counted. Inside of your application, there's lots of things that can be counted. Create metrics for those. And then think about, you want to create metrics for data that you might need to query for diagnostics or performance. So sometimes things aren't happening right, or not happening like you think they should. Create metrics for those. But also you want to think about performance. Am I getting the right RPS or QPS? Think about that. But the most important piece is, and this is all capital letters, is do not use metrics for billing, because in a lot of systems, if we cannot collect our metrics, or there is a blip, we'll just drop them. And that's cool for a graph on a dashboard, but if you're trying to make money off these, use something else, probably with transactions, to make sure they got stored. So best practices for metrics. And I'm trying to be very vendor agnostic here, but open metrics is an open standard, so I will say that. Use this. And what we're finding is, like, tools, like I'm from VMware and we acquired Wavefront. Wavefront saw that it was very important to talk a language that everyone understands. So Wavefront, Datadog, I'm guessing SignalFX, everyone understands Prometheus metrics formats, or the open metrics format. Use the scripted names and labels. Before we did HTTP requests total, but remember we put labels on those. So use those to be able to describe your data in a great way. And then also here's a very important thing. Your application, if it's super complex, might have hundreds of metrics. If you have thousands of metrics, you're doing it wrong. And not in the way that we're going to come berate you, but use that as basically as an indicator that you might have too many. And so next piece here, endpoints. How do I know if my service is up? I don't know. How do I know if my service is ready, which is different from the process just running? If service sub 1 relies on service sub X, how can I tell when service sub 1 is degraded? So I have an application that requires a database. How do I know if my application is broken versus my database being broken? This is what we should use endpoints for. And real quick here, there's a couple types of endpoints. So you can have us like a TCP. I hit a TCP port. If it returns, or if it actually can connect to it, hey, my application's up, good to go. But sometimes we actually want it to return a request. So maybe we have it return an OK or a timestamp. That's another thing we can do. Or maybe we can get even better. We can actually create maybe a JSON document that we can, or a TOML document, or whatever you want to use. And it can actually say in the document that here is the things that I depend on, and this is the reason why my application is not working. So now you can build tools that, instead of saying that service 1 is broken, we can actually say that service sub MySQL is broken. So endpoints. Use an endpoint to signify the service is up. Expose an endpoint to signify the service is ready for traffic. Kubernetes actually got this right, where they have the liveliness and readiness probes, because just having a binary running does not mean that it actually works. And the last one is with the custom endpoints. I don't see this enough, but we should actually be showing how our applications are working, and it shouldn't just be binary yes or no, I'm working. It should be I'm working or I'm not working because something behind me is broken. All right, so chapter 4, traces. I'm not going to go super deep into tracing. This is like an hour talk in itself, but I will hit the highlights. Applications are composed of multiple services. True. Distributed tracing is used to profile and monitor applications. That's a fact. And what we do now is we can think about the processes of our applications. We define those as spans. A span goes from here, and there's a lot of things that happen. We can combine those spans together to create timings and see what our application is doing. But then what we can do is we can actually use spans between multiple services. So now we can have a long-running service, like you're working at a bank and you're doing a deposit. You can actually see exactly what the application is doing across multiple applications, or in clients too. Here's a picture from an application called Jaeger, where it's one application, it's just a front end, but we can see that it's doing things in parallel. We can see that there's a stair step thing here. Maybe that can be concurrent. And then we actually see below the stair step that there are concurrent things. So tracing can help you see that things are working, but it also can help you see how well things are working. And the neat part about tracing now with the Open Telemetry project is now we can actually combine tracing and metrics, so we can actually see all this at the same time. And so, going on to the end, pulling it all together. Like I said before, I'm not here to really talk about any project, but I think this is important, Open Telemetry, that we should be thinking about the ideas that are being put forward. So thinking about metrics and distributed traces as first-class citizens of our projects. And then realizing, this is the most important piece, actually, of the whole entire talk, is that this is hard. You will not get it right the first time. This is one of these things that I'm encouraging people to try, to think about logs, metrics, and tracing as first-class citizens of their applications, but in always improving them and not giving up when it gets hard. And I don't like talking about observability because it's not a word in the dictionary, but I will say that the goal of these practices is making your systems more observable. That word is in a dictionary. And next steps. First thing, understand that you don't do monitoring. It is a practice just like I say, if you were a developer, so you're just going to go develop our way out of here. No, us as developers, we're way more complex than that. We like coffee and nerd stuff, and we write code sometimes too. So we're more complex than that. Monitoring is more complex than that. We don't just do logs, tracing, and metrics. We are using these things as tools to help our applications run better so we can make more money and have more time for nerd stuff, coffee, and whatever. So that's the last slide. I just want to say one thing. Thank you all for having me. I am from Baltimore. It's crazy to see conferences coming to my town, and I don't have to get on an airplane. I wish more conferences did this, and thank you all for not booing. Yeah.